this video, we're going to go over how to write a transition rule. We're basically writing in mathematical terms whether you are moving the point up, down, left, or right. If you're moving something left to right, in mathematical terms, you're moving across the x-axis. If you're moving something up and down, mathematically that's moving along the y-axis. They want us to write a rule so we don't have to write down the words where we have to say, I moved up 5 spaces, I moved to the left 3 spaces. They need you to write that mathematically. Another thing we need to notice is where it's moving to. The letters with this little mark above it is the end. It's where the image has moved to. This is the original image, and it has moved to this one right here. So this image is moving from here to here. How do I know that? These letters have this little mark on it. That little mark is telling us that's the end product. That's where it has moved to. But this little mark is telling you that that's the end spot, that it has moved from here to here where it has these little marks. My translation rule, the way I write it, has to be written mathematically. That means I'm going to take a point, which is an x and a y, and this is how I write a point in mathematics. I use this little arrow telling me I'm going to translate it, and in this box, I need to write down mathematically how I'm moving the object. Remember, if I'm moving left or right, it's going to be an x, because you're moving along the x-axis. And what I do is I pick one single point. I pick that point and I see exactly what I'm doing to move it from here to here. And I need to see, since I'm dealing with the x, whether I move it right or left. If I move it right, it's going to be plus. If I move left, it's going to be negative. So since I'm moving from here to here, I need to move left first. That means it's going to be minus however many spaces I need to move. So let's see how many spaces I need to move. 1, 2, 3, 4, 5, 6. 6 spaces. That's my rule for moving this image left and right along the x. Now I need to see how many I need to move up and down. Remember, mathematically, the up and down is the y. So I had to move 6. Let's check it again. 1, 2, 3, 4, 5, 6. And then I need to move up. How many spaces did I need to move up? 1, 2, 3, 4, 5, 6, 7. Since I'm moving up, it's going to be positive. If I was moving down, it would be negative. 7 spaces. So let's check that again. I'm going to move to the left 6 spaces. 1, 2, 3, 4, 5, 6. That's the reason it's a minus 6. And then I'm going to move up 7. 1, 2, 3, 4, 5, 6, 7. This is my rule for moving this object. We're going to write a translation rule for the following. Remember, a translation rule is simply writing mathematically how this object moved from one spot to the other, how it moved up and down or left to right. Remember, this little mark right here tells me that this is the end. This is where the object ended up. This is where it started. So it's moving from here to here. To write a transition rule, I need to describe mathematically how this object is moving. If I move left to right, I'm moving along the x-axis. So I'm going to write down x. I need to describe how E is moving from here to here, and I only have to pick one point. I don't have to do it for every single point, just one point, because the rule is going to apply to all the other points. If I move from here to here, is it moving right or is it moving left? It's moving to the right. If I move to the right along the x, that's going to be a plus. Now I need to see how many spaces it is actually moved. So let's count that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 spaces. So I'll put a 10 right here. Now I need to see how many it moved up or down. If I moved up, it's going to be a plus. If I move down, it's going to be a minus. And moving up and down is moving along the y-axis. So I'm going to write a y right there. And I need to see how many I'm going to move up to get to this spot. 1, 2, 3, 4, 5, 6. Plus 6. This is my translation rule for translating this object from here to here. One of the reasons we write a translation rule is because it will help us with problems like this. They want to know the coordinates for each one of these points once you translate it using these instructions. So what I'm going to do is I'm going to write a translation rule and then apply it to each one of these points. My translation rule is going to look like this. It's going to start off with X, and then I'll look and see whether or not I'm moving it left or right. And it tells me right here I'm moving it left 8 spaces. If I move to the left 8 spaces, that means I'm going to be subtracting 8. If I move down 10 spaces, that means I'm moving along the y-axis, and I'm going to subtract 10 from whatever y I have. I'm going to write down the coordinates for each one of these points and then apply it. Apply this translation rule to each one of these points. So let's look at point P and get the coordinates for point P. The coordinates for point P, I go back 1, that's -1, and then up 1, 2, 3, 4, 5, 6. Now I'm going to apply this translation rule to this point. My x is -1 minus 8, and my y is 6 minus 10. Once I apply this rule, my brand new point for P is going to be -9, and then 6 minus 10 is -4. And I use this little mark right here to tell me that this is my new point for P. I'm going to write down the coordinates for Q. The coordinates for Q, 1, 2, 3, 4, 5, 6, 7. 7 is my x, and my y is 1, 2, 3, 4, 5, 6. And then I'm going to apply these numbers to my translation rule, which is telling me to take 7 and subtract 8, and then take 6 and subtract 10. Once I do that, I'll get my new point for Q. 7 minus 8 is -1. 6 minus 10 is -4. Now I need to apply the rule for R. I need to find the coordinates for R. The coordinates for R are 1, because I go over 1 and up 1, 2, 3. I'm going to apply my translation rule to these numbers. 1 minus 8, and then 3 minus 10. 1 minus 8 is -7, and 3 minus 10 is -7. That's my new R.